going to have a short video on how to do Cramers Rule using determinants for a 3x3 system of equations. For example, we have three variables x, y, and z, three equations, and a constant on the right. Now some of these could be a zero, so if you had a 0 y here, you would just have the x and the z term written. You wouldn't even have the y written if there's a 0 coefficient. But the letters in front of the x's, the y's, and the z's are the coefficients. These are the constants. The first thing you got to do to solve system of equations is to find a coefficient matrix of just the three columns of coefficients from the x's, the y's, and the z's. So the ADG's of the x, the BEH's of the y's, and the CFI's of the z coefficients are all put together. You find that determinant, and you'll be using that later for solving the x, y, and z. For the x, y, and z, you must find each of those using the coefficients along with the constants. So for the x, if we're going to find x, we remove the x coefficients, stick the constants in place of that location, so JKL up front where the x's are. We keep the coefficients for for y and z, there they are. And then once we have that determinant, we divide by the coefficient matrix or coefficient determinant to get x. For y, we stick these constants where the y coefficients go. So we have the x coefficients, as they're seen here. We have the z's, as they're seen here. We replace the y coefficients, B, E, and H, with the JKL here in the middle. And the last one for the z, you keep the x coefficients, the y coefficients, there they are, and replace the z coefficients with the constants from here to there. Again, divide by the coefficient determinant when you're all done. Now, an easier way would you just find two of these and stick those two for answers, x or y or y, z, whatever two you have, and put them back into one of the equations to find the third variable. That will save you some more. Just a quick overview of Cramers Rule for a 3x3 system. The three variables x, y, z have coefficients. Here are the x coefficients, y coefficients, z coefficients, and then the constants. The first thing you do is you take all the coefficients, x, y, and z coefficients, put into a matrix, and find the determinant A. That comes in handy when it comes to finding our x, our y, and our z. Now to find the x, you take the constants and put them in for the x coefficients, and you keep the y and the z coefficients where they are, perform that determinant, and divide it by determinant A from up here. For y, you keep the x coefficients and the z coefficients in place and replace the y's with the constants again from here. And for z, you keep the x coefficients, the y coefficients, and replace the z coefficients with the constants. Again, everything divided by determinant A, which you found above. Here goes number 32 from the packet. I've already got the numbers set up. So for determinant A, with all the coefficients of the x, y's, and z's, doing our angles here, and we're going to go -1, is -1, 1, 4, 1 is 4, 1, 4, and 2 is 8, minus, going up now, -1, -8, 1, 4, 1, -4. Quickly simplifying, this looks like it's 11 minus a -13. The double negatives gives us 24. That's determinant A. We'll be using that to find the x, the y, and the z. Well, I'm going to look for x and z, and to find then the y, which would be in the middle, I'll just use these two answers with one of the original equations, maybe the first one, put the x and z in, and I can just solve for y. So here goes finding x. Everything's laid out for us already. Our three diagonals. -3, -1, -1 is -3. 1, 4, and 9 is 36. 1, 14, and 2 is -28. Minus, going up. 9, 1, 1 is -9. 2, 4, -3, I see it's 8 and 2, -24. And +14. I'll combine all these. This becomes an 8. It actually becomes a 5. minus, that's a 10, negative 10. Okay, 4 is a negative 10. Yeah, negative 19. This becomes a positive 24. Now, again, this is defining the x. I divide that by the determinant a I found above. So 24 divided by 24. Again, this is all x equals 1. All right, now we're going to go find z. Again, the constants are where the z coefficients are. This is the x coefficients, the y coefficients, the two columns. Going through this pretty quick. Negative 1, 9 is positive 9. This is going to be a negative 14. This is negative 12, negative 24, minus, going up, 3, 28, and 36. Simplify here. This is, let's see, negative 38 plus a 9 is negative 29. Negative 29, I guess. Okay, boy, 60, 50, 64, 60, ooh, let me think. 50, 64, 67. Okay, and that's double negatives. So 6 is, 96. Negative 96. Again, this is for my z. So again, z equals, z equals, z equals. Well, again, looking from those, I got to divide by the 24, determinant a. Z equals negative 4. Hey, now look, I have my x, I have my z. I can find y using one of the original equations. So here's my original equation. I'll use the first one. It's negative x plus y plus z equals negative 3. Here's my x value. Here's my z value. I'll put them in, find for y. So it's negative 1 plus y minus 4, because it's just a plus z and z is negative 4, equals negative 3. This becomes a negative 5. So y minus 5 equals negative 3. Add 5, y equals 2. And there you have it. Oh, geez, you see that? I combined this to negative 4 and 1. So x is 1, y is 2, z is negative 4. That's it. Good luck.